Good day, everyone. Today I'll present an article titled "The Influence of Drying Protocol on the Setting and Crystalline Phase Formation of Calcium Silicate-Based Sealers." It was done by Brazilian group and was published in Australian Endodontic Journal 2025. Endodontic treatment depends on homogeneous seal that prevents bacterial colonization, and calcium silicate-based sealers are favored for their bioactivity and biocompatibility, but their performance depends on hydration reaction that produces calcium hydroxide. These sealers exist in two forms, either ready to use, which contain no water and rely entirely on external moisture from dentin to initiate setting, and powder and liquid, which begins setting immediately upon mixing as they contain internal water. In this study, they used BioC sealer as a ready-to-use type and BioRoot RCS as powder and liquid. They aim to determine if different clinical drying protocol significantly impact the setting and chemical formation of these materials. They used 32 human teeth, which were embedded in resin and sectioned into 2 mm slices representing the cervical, middle, and apical thirds of the root. They had two experimental groups: dry group, where the canals were aspirated and then dried with 8 cp per points until visually dry, and moist group, where the canals were aspirated but not dried with paper points, leaving residual moisture. Then they used different tests to evaluate the setting of the material. Setting time tests using modified Gilmore needle, and this test determined how long it takes for a material to harden. A needle with 1 mm tip was applied to the sealer surface every 10 minutes, and complete setting was recorded when the needle no longer left a visible indentation. Raman spectroscopy. This chemical analysis technique uses laser light to observe vibrational modes in a molecule. It was used to identify specific chemical functional groups and crystalline peaks at fresh 1-day and 28-day intervals. Fourier transform infrared spectroscopy, and this test measures how much infrared light a sample absorbs at different wavelengths. It was specifically used to characterize the hydration process by tracking the presence and reduction of water over time. And lastly, the X-ray diffraction, which is a primary tool for identifying crystalline structures of a material. By measuring how X-rays scatter off the sample, the researchers identified the specific minerals formed, such as calcium hydroxide. For the results, as for the setting time, moisture was critical for the ready-to-use sealer. BioC sealers set significantly faster in moist canals compared to dry canals. And for BioRoots RCS, moisture had no significant effect on setting time. For the spectroscopy, it confirmed that BioC sealer in moist canals had much more prominent water peak initially than in dry canals. Raman spectroscopy identified a calcite peak in both sealers, which is associated with the carbonation of the material during setting. For the X-ray diffraction phase formation, after 28 days, calcium hydroxide was detected only in the moist BioC sealer group, and BioRoot showed evidence of apatite and calcite but no calcium hydroxide peaks in this specific model. So while BioRoot RCS contains enough internal water to set regardless of canal dryness, ready-to-use sealers like BioC sealer are highly sensitive to the drying protocol. Interestingly, even in dry BioC samples, a setting eventually occurred, likely due to the ambient humidity or trace moisture within the sealer. The presence of calcium hydroxide in BioC but not in BioRoot suggests differences in how these materials release ions within the root canal environment versus in water immersion tests. So for the conclusion, dentin moisture is essential for the proper hydration and setting of ready-to-use bioceramic sealers. For clinical practice, they recommended that root canals should be kept slightly moist rather than completely dry when using materials like BioC sealer to ensure optimal setting and the formation of calcium hydroxide. And thank you so much.